Muy bien, vamos a tener la oportunidad de hacer preguntas, 20 minutos en el panel al final de las presentaciones, pero nuestra siguiente presentación va a ser de Offworld. Nada más denme un segundo. Ya tenemos a Jim en línea. ¿Sí? Pero bueno, lo voy a presentar. Jim, can you hear me? Perfect.
Yes.
Okay, I'm going to make a quick introduction, just a second, but thank you, Jim. So, Jim Kerevala, el cual ven en la pantalla, es el CEO de Offworld de Estados Unidos, quien presentará el tema de Artificial Intelligence in Mining, The New Paradigm. Jim lidera una de las compañías más innovadoras en robótica autónoma, aplicada tanto en minería terrestre como en minería espacial. Y su visión integra la inteligencia artificial, automatización y la exploración planetaria. Thank you, Jim. The floor is all yours.
Thank you, Carlos. Greetings, everyone. I hope you can hear me okay. And it's a real pleasure to be participating. And Carlos, you're a hard act to follow, as well as Angel. It's very nice to see you. So, what I want to talk about briefly over the next 10 minutes or so, I'll try and keep it quick, is just about the general applications of artificial intelligence in mining, but also the context of why we're doing that. Why is it specifically important? And why we can't just scale in the same way that we've scaled mining for the last 150 years. So really, the challenges that we have as a civilization are quite extraordinary. And if you can, hopefully you can see the screen okay, coming through. But as Carlos and Angel both alluded to, we are at a critical moment in history and in our future. In fact, we may be the pivotal generation. As Carlos was talking about the explorations to the New World in the 16th and 17th and 18th centuries, we are really entering the exploration and the movement to a new world now. And the challenge with that is it's really hard to do that with people going out into space to try and build an infrastructure with an astronaut in a suit and then having holding tools or controlling tools directly. In order to really scale, in order to really build out the future, we need autonomy. And we need autonomy to an extent that we haven't even considered it before in terrestrial mining. But how do you get from here to there? How do we create that civilization leap into the solar system, starting here from the ground and building that experience to scale? Well, one example is what my company is doing at Offworld. The objectives of what we're doing is to take machine intelligence and sensing and embed that into autonomy and robotics in such a way that you do not need humans in the loop for the dangerous tasks, for the physical labor, for the high-risk roles and activities that are required to do. And it's essential that we make these changes with machine intelligence, not just for greater profitability, but because the demands of our civilization's growth are putting such a pressure on the world around us, whether we agree or not about the impacts of the growth of our civilization. The demands on metal and mineral in the years to come are going to be significant. We are looking already terrestrially, just in the next couple of decades, at increased demand of critical minerals that would place our environment at such risk were we to mine that mineral conventionally. If we just carry on business as usual, the challenges that we will face and the impacts that we will incur will be of our own making. We will push ourselves over the climate cliff, trying to open up hundreds of new mines, digging up thousands of tons of mineral across millions or tens of millions of tons of ore, just to build the systems that should allow us to use less hydrocarbons. It is a fallacy of our long-term civilization planning that we can do this conventionally. So if we're going to have to figure out new ways to undertake machine intelligent operations, we really need to figure out many different ways of how we are going to do mining in the future. And some of the critical challenges we face really open up extraordinary opportunities with machine intelligence, with artificial intelligence, and integrated sensing, and then taking all those capabilities directly to the most dangerous points of the mining process, where you can then use them in real time to increase your data and information and decision-making capabilities. So we can use machine intelligence in exploration and resource estimation. And we are trying to use this today across the industry for data analysis across geological characteristics to predict how the mine will increase its operations, its productivity, its profitability, and to utilize far-field remote sensing imagery, integrating imaging from satellites with ground sensor data for calibration can create greater confidence of information, greater confidence of mineral reserves and planning. And we can take that information for mine planning and design to help optimize algorithms, to help build mine layouts, scheduling, improve hauler planning and route planning, and use that to increase digital twin development as well. By integrating the sensory data at the start of the rock face extraction, taking that along the development path of mining and operations, we can create digital twins with AI optimization across that entire mine planning process, which will enable us to undertake real-time autonomous decision making support so that we can have AI agents in the mining supply chain, in the mining process chain itself, optimizing mine development and mine architecture. And then the real benefits where Offworld is really developing further activities is to then take this intelligence and the applications of that autonomy and place it into robotics and vehicles and systems so that we can have end-to-end material handling, extraction, supply chain, and processing, and then take that to refining and processing the material as well, so that we can control the optimization of which batches of ore get crushed at which rates. We can regulate the grinding, the flotation, leaching and smelting processes, and create increasing autonomy across all of this. And using image recognition systems, for example, in the sorting facilities, we can use computer vision to identify and separate the ore from waste, both optically and with other sensing capabilities. And again, the real advantage of all of this is that we can bring what is currently a very siloed, very isolated industry in terms of information management and data handling and bring that together in terms of increased capability to allow the information silos to break down and create a unified data architecture and structure to allow optimization to occur in multiple places at a systems level. This is the real exciting opportunity. And what's so tremendous about this is that there's so much low-hanging fruit. There is, even with efforts undertaken by many mining companies today, we are still scratching at the surface of what is possible. We're optimizing existing processes, adding autonomy to existing vehicles, sensing existing material handling pathways. The real opportunity for machine intelligence is to put multiple levels of collaborative intelligence, embed them in robots and systems that undertake different tasks and activities of end-to-end capability. And this is what we're doing at Offworld. Our objectives at Offworld are to put autonomy right at the rock face, break the rock with robotics, use energy to get inside the rock rather than physical structures, and then have an end-to-end supply chain of vehicles and systems and sensing and intelligence that allow us to create not just the mine of the future, but the mine of the solar system. With autonomous excavation, intelligence, sensing, and then energy beam deposition, we can separate ions of metal as close as we can to the original location. And just instead of moving millions of tons of ore out of a rock, a mine every year, we're moving hundreds of kilograms of metals in treasure bots. And that's our objective, is to embed this intelligence into this capability that will allow us to take our hands off the joysticks or the wheels or the control panels and allow the robots to do the tough jobs. This is one of our excavators operating in Platinum Mine in South Africa. And this is using closed loop sensing, force feedback functions, optical ore body recognition. And these were early stage experiments, both with machine learning and with much more path planning put in place, but none of it with direct human control. So all of the operations that you see were completely autonomous. And this was really one of the world's first examples of pure autonomy in underground mining. And the advantages of bringing AI in and robotics into mining are literally to break through on the economics, to increase safety, to enable a huge environmental impact, and also to revitalize local communities. One of the biggest concerns and fears I hear all the time is, well, surely if we bring more robotics and autonomy, this is going to disrupt our community's jobs. This could not be further from the truth. Our young men and women in the late 20s and 30s will increasingly not want to go into mine operations. They will not want to go deep into the mine body itself. What they'll want to get on and do is 21st century intelligence robotic mining, where the future is the fourth industrial revolution for learning in intelligence, machine learning, robotics, electronics, sensing, and systems that can be applied for many different applications. And we're taking all of that promise and capability and embedding in our first species that we're deploying is a multi-payload, all-terrain rugged surveyor system. The surveyor can take many different types of sensors, and it can go in locations that human personnel just cannot go. And this will allow us to go into post-blast sites. And one of the real benefits of machine learning optimization and taking artificial intelligence is not just which sensors you can put it in, it's having the right data captured at the right moment, distilled via the optimum intelligence into the right information, and handed over as making actionable intelligence to the decision makers. And by the end of 2025, we will be rolling out our hyperspectral and LIBS equipped surveyors, and bringing a GPR payload by mid-26 as well. And with the data fusion platform that we now have, we'll be able to accelerate exploration by many orders of, by many multiples, in between first remote sensing data inference and then core drilling for exploration. We can accelerate and optimize the core drilling decisions and even drop lip sensors down the core holes for immediate full elemental data analysis. That leap in mining exploration intelligence that is coming in real time in mining exploration operations over the next 12 to 24 months is the direct precursor to where we want to go in the 30s as we head out to the moon. The moon is, as Carlos and Angel explained, is rich in resources and opportunity. We've been developing optimization experiments for extracting water from regolith simulant and then actually condensing to capture the first drops from an experimental perspective. And the idea being that we then take these capabilities and all of that machine learning, all of that intelligence learning that we've undertaken through our terrestrial operations, which will be ongoing, and then build on the production lines that our terrestrial robots are coming out on, the first lunar swarm robotic mining systems in the early 30s. And the idea is that we can then scale with full autonomy, with robust machine-informed robots that have already had millions of hours, robot hours, of operations on this first planet. And then we can go to the moon as a second celestial body. If, as a community, we get this right, it's a big vision and it's a big mission, but it is an essential one for our generation to undertake. We do not know whether the next generation has the bandwidth, whether we have the resources, the economy, or the geopolitical stability to make this grand leap. But if we get this right, we can expand to the moon, into the solar system, and have a flourishing future for generations to come. That's why Lunar ISRU is the pivotal objective for this generation. With that, thank you very much.